Hello class, in this video I'll be showing you an application of right triangles. Let's begin. A security camera in a neighborhood bank is mounted on a wall 9 feet above the floor. What angle of depression should be used if the camera is to be directed at a spot 6 feet above the floor and 12 feet from the wall? So I'm going to start by drawing a diagram. I will draw the height of the camera first. So this is 9 feet. And the camera is directed at a spot that is 6 feet above the floor and 12 feet from the wall, like such. Next, I'm going to draw the line of sight for the camera. And then I'm going to draw a right triangle. I'm going to complete the right triangle, like such. And we know that this is also 12 feet. Okay, so now with the diagram drawn, the problem is asking what angle of depression should be used if the camera is to be directed at the spot 6 feet above the floor and 12 feet from the wall. So here's the camera looking down. Here is the horizontal line of sight for the camera. So this is the horizontal line of sight. This angle from the horizontal line of sight to the red line, that is the angle of depression. Okay. I'm going to put an angle right here. We're going to call this theta. And my claim is that the angle of depression is equal to 90 minus theta. And I say that because the horizontal line of sight and the wall make a 90-degree angle. So the angle of depression will be 90 minus theta. So if we can find the value of theta, we can find the angle of depression. So the first trig function that comes to mind is sine. And that's because we are given the opposite side. However, you also need the hypotenuse. And though it is possible to find the length of this hypotenuse, it's also a lot of work. So what I want to do is I want to work efficiently. So what I'm going to do is instead of using sine, which is the opposite over the hypotenuse, I'm going to use tangent, which is the opposite divided by the adjacent side, which I'm about to highlight in pink. We can find the length of that adjacent side pretty easily. That is going to be 9 feet minus 6 feet, which will be 3 feet. So now we can write the tangent of theta is equal to the opposite side divided by the adjacent side, which is equal to 12 divided by 3, which is equal to 4. So the tangent of theta is equal to 4. And you may remember from the inverse trig section, if tangent of theta is equal to x, then the inverse tangent of x is equal to theta, as long as theta is between negative pi halves and pi halves, which would be negative 90 degrees and 90 degrees. So we know that the tangent of theta is equal to 4. This implies that the inverse tangent of 4 is equal to theta. And so what I'm going to do is I'm going to go into Desmus, and I'm going to evaluate the inverse tangent of 4. Oh, looks like I already did it. So the inverse tangent of 4 is 75.963. And if you want to figure out how I did that, first make sure that Desmus is in degree mode. Hit Functions, Inverse Tangent, 4. And so that theta is 75.964. So theta is approximately 75.964. So the angle of depression is 90 degrees minus 75.964 degrees. So the angle of depression is 14.036 degrees.